fractions, that's just using addition, subtraction, multiplication, division, exponents, things like that in applied problems. So by applied problems, I mean real world scenarios. Okay, and then computing the mean. A mean is just an average. We have a word problem. This is a real world scenario. Jorge bought a car for $18,340. He paid $2,500 down and then paid the rest in equal monthly installments over a 4-year period. So we want to find out how much are his monthly payments, and we're pretending there's no interest. Very unrealistic, but we're going to pretend that there's no interest. Okay, so first let's look at the information. Here's what's given to us, like given information. The car is $18,340. The down payment is $2,500, and he paid for 4 years. Okay. And we want to find out how much are his monthly payments. So we want to know monthly payments. Okay. From here we need to come up with a game plan. Okay, first of all, we have years, 4 years. We want to know how many monthly payments is he going to make. So 4 years times 12 months in a year gave me 48 months. So that's how many payments he's going to make, 48. Now, if the car was $18,340, he paid $2,500 down. I'm going to subtract. So I'll do 18,430, sorry, 340, being dyslexic, minus 2,500. So 13 minus 5 is 8, 7 minus 2 is 5. So this is how much he still owes after his down payment. So then if I take that 15,840 and I divide it by 2,500. Actually, I'm going to write that a little further over. I want to show you a nice trick. When you're dividing numbers and the number you're dividing by and the number you're dividing into both have zeros on them, zeros can cancel each other out. So 1 0 out here will cancel 1 0 in here.
How did you get the 2,500 to divide by that? I thought it was the 48 months.
Oh, you're right. It's 40. You're right. It's 48 months. Thank you. I don't know what I was doing. You know what I was doing? I was thinking about, ooh, dividing by zeros can cancel, and then I got excited and went in the wrong place. You're absolutely right. Thank you. Good catch. You're right. 48 months, and now we can't cancel anything at all because there are no zeros on that. That's exciting. 48 will go into 158. The easiest way to figure out the number of times this will work is if I look at the first digit here, 4. Well, actually 48 rounds to 50, so we could look at a 5, but if I look at the first digit, the 4, and I look at 15, 4 will go into 15 3 times. Now that tells me that I need to either have 48 times 3, 48 times 2, or 48 times 4. It will always be exactly the number you estimated, one more or one less. So if I try 48 times 3, I'm going to get 144. There won't be another 48 that fits in there. So 3 was the correct amount. And then I subtract, bring down that 4, and look at that, 144. We already had that answer, so that's 3, which will give me 144. And oh, I'm going into my, hold on, weight and fat. Let me just erase that out of my way. So 144, bring down my 0, it goes into 0, 0 times. So my payments will be $330 a month. Again, okay, Linda is driving from Clayton to Oakley, and she can go directly from Clayton to Oakley on a mountain road, but she can only drive 40 miles an hour, or she can go through another city called Pearson if she travels highways, and she can go 60 miles an hour. Now, the book gave us a picture of this, so we have the actual miles. So she's starting at Clayton. So here's your start. Okay, and to go from Clayton to Oakley, it's the direct route, but she can only go 40 miles per hour. To go from Clayton to Pearson to Oakley, she is not taking the direct route. I don't know what's going on with that. But she can go 60, right? It was 60? Yeah, 60 miles per hour. So she can go the long route through Pearson, and it ends up being 60 miles per hour. So you want to figure out which route was the fastest. To figure out if you can going 120 miles and you're going 40 miles per hour, am I going to multiply or divide? Divide, yeah. So 120 miles. I'll do this. We do 120 miles. Seriously? So I'm going to do 120 miles. I'm going to divide that by 40 miles per hour. I'm dividing. So I like to write my division this way because as you get into algebra, all of your division gets written like a fraction. And plus, this is a really good visual for canceling the zeros. So that's 12 divided by 4. And 12 divided by 4?
3.
So that'll be 3 hours. And this is the straight route. Now the long way, faster but longer. Before we can figure out how many hours it's going to take her, we need to figure out how far is she driving. So we're going to add the two distances together from Clayton to Pearson and then from Pearson to Oakley. So it's 180 miles total. And then I'll take that 180 miles and I'm going to divide it by 60 miles per hour. Again, my zeros can cancel each other out. So I've got 18 divided by 6. 3 hours. Okay then. It will take her exactly the same length of time. Now the question asks us which route will take less time. They're the same. If the question was which route is more efficient, same amount of time, but if you're going less miles, and it's going to take you the same length of time, when you want to drive less miles to put less wear and tear on your car, use less gas. So the straight route would be the most efficient. A a fence. We've got a fence or corral shown in the figure. However, no fencing is required on the side adjacent to the barn because, well, you've got a big old barn right there, so you don't actually need a fence. You've got the barn wall, right? If the fencing costs $4 a foot, what is the total cost? Well, first we have to find out how many total feet of fencing. So we're going to add up all of these numbers. So 5, 14, 5, 8, 10, 12, 14. So you've got 1,445 feet of fence. And to find out how much that costs, what application am I going to use? Oh, yes, I added all those. To find the total distance, I added the 475 plus the 300 plus the 275, 200 and 200. Oh, wait, I added wrong.
1440.
1450. I lost this 5. I only saw the 1 5 when I was doing that. So apparently my brain is not functioning properly today. I apologize. I think it's with the computer. It's not wanting to work. Okay, so I have 1450, so 1,450 total feet. What will I do to find out how much that costs? It's $4 per foot. Yeah, I'm going to multiply. So I get 0, 5 times 4 is 20, carry my 2. 4 times 4 is 16 plus 2, carry my 1. 1 times 4 is 4 plus 1 is 5. So this fence will cost $5,800. Mean means average. So these two words are interchangeable. They're the same. So I could say mean is this, or I could even just say average was the same thing. Now the sum of the values. So you have a list of values, right? Add up the list. That gives you the sum of the values. And the number of the values is you count how many things you added. We took 6 tests in chemistry, and we're just going to double check that. That's 1, 2, 3, 4, 5, 6. True. We have 6 tests, and we want to find her average score. So the first thing we want to do is we need to add all of these numbers together. Okay. And then we're going to divide that by 6. Because she took 6 tests. Now, some of you can probably add this sideways that way. Some people might have a harder time with it. So we can add down 17, 18, and then add the next test. And then add the next test. I did 89, 91, 72, 86, 94. Plus 96, and that's all 6 tests. So this is going to give me 528 divided by 6. So 6 will go into 5 no times. It'll go into 52 8 times. So her test average is an 88%. So if her grade was totally on test, she'd have a B. When you're talking about numbers, we start out with a set of numbers called the natural numbers. That's the smallest set. And they're natural because they're natural. It's counting 1, 2, 3, 4, 5, 6, 7. So we start 1, 2, 3, 4, 5, 6, etc. forever and ever. All positive, no fractions, no decimals, just the numbers you'd count with. And then the next thing we get are whole numbers, which are kind of like the natural numbers, except we start with 0. And then they go forever. So integers, the negatives didn't copy, weird. Integers are all of the positive and negative whole numbers. There are no fractions and no decimals. And they go on forever in 2 directions. Negative numbers are things that are, well, integers, negative integers are things that fall below 0. Debt, if you owe money, that's a negative number. If you're below sea level is at 0, is considered 0. So here we have liquid nitrogen freezes at 346 degrees below 0. Now if you think about that, water freezes at 32 degrees. So 0 is actually below what we consider freezing point. And then we'll go 346 more cold than that. So this is going to be negative 346 degrees Fahrenheit. Dead Sea is on the border of Israel and Jordan. It's the lowest land area on earth. It is 1,300 feet below sea level. So that would be negative 1,300 feet. And if your 10-year-old daughter weighs 14 pounds more than the average child, well, that will be positive 14, because it's more than the average. So this is a traditional number line, -1, -2, -3, etc. You can also write them this way. If you put 0 in the middle, positive numbers are above and negative numbers are below. So if it would make more sense to you, like visually, to draw a number line this way, you can. So it just so long as on a horizontal number line, the positive numbers are going to be to the right and the negative numbers are going to be to the left. Vertically, positive is up top, negative's down below. So if it makes more sense for you to draw a number line this way rather than this way, you can do that. Okay. So this is traditional, or you can rotate it. Okay. So positive numbers, negative numbers. Right. Everything on a number line, if you're going horizontally, anything to the right will be greater than anything to the left. If you're going vertically, well, everything on top will be greater than anything below it. If I have -7 and I have -4, -4 is to the right of -7, so it is greater. And another way to think about this is if you think of negatives as money, if you owe $4, you're doing better than if you owe $7. So you actually have more money, so it's greater. 0 is greater than -4, and 2 is greater than -7. Positive is always greater than negative. It's better to have $2 than to owe somebody $7. It's actually better to have $0 than to owe somebody $4. Absolute value is distance. And it's distance on a number line. Okay? And absolute value is always positive. And the reason absolute value is always positive is because if I walk a mile forward, I walked a mile, correct? Well, if I walk a mile backwards, which would be kind of like in a negative direction, I did not walk a negative mile. I still walked a mile, no matter which direction I was pointing. So absolute value is positive because it's distance, and distance is always positive. It doesn't matter if, if I walked a mile on my hands, I'm still walking a mile. It's always going to be the same distance. Thing the way it's written, the symbol for absolute value is 2 bars. So this is the symbol for absolute value. And anything that's inside this, we want it to be positive. So basically, here we have a -5. Absolute value is positive, so this equals 5. That absolute value symbol is saying take whatever's inside here and make it positive. If it's already positive, it stays that way. And technically 0 is neither positive nor negative, so it's just 0. But that's what these 2 straight bars are always going to tell you, is you take whatever's inside there and you make it positive. Opposite is different than absolute value. They're the same distance away, but you're not looking at the distance. So you're not talking about positive. You're just, opposites are the same distance away from 0. So opposites are the positive and negative of the same number. Okay, so in this case, 2 and -2 are opposites. And that's true for any number. 3 and -3 are opposites. Or you could write the -1, 4 first. -4, why I'm going in order, that's annoying. -14 and +14 are opposites. This is the opposite of a negative. That's called a double negative. And if you think about double negatives in the English language, they cancel each other out. So, okay, I'm going to speak very poorly. If I say, I ain't got none, the ain't and the none are going to cancel each other out, and that really means I have some. Right? I also like to do this. Double negatives make me think of a really smiley person. See, he's happy, and that is positive. Right? So, little smiley guy. Doesn't he look like it looks like eyes, and I don't know, it works for me. So double negatives, if you can think of it, double negatives cancel each other out. You can do the smiley guy, and that's +2. If you like to connect dots, oh, look at that, it's a big giant plus. Okay. I've actually seen people do this before, where they come in and they go like that. Whatever works for you, just so that you know, if you see those 2 negatives like that next to each other with a parenthesis, it's going to become positive. Double negatives work here. This is a double negative. This is the opposite of an absolute value. And this is how that works. If you think about the difference between a curve and a wall.
Yeah, what's the difference?
Okay, parentheses are just like a separation. So what happens is I have this and I have a curve, so I can slip that in there like that. And what I'm really doing is I'm multiplying here. I'm saying a negative times a negative, and that gives me a positive. That's what's really happening. So I can slide in there because it's got this curve. And so this is going to give me a positive 9. However, if I look at this example, I try to go, I'm going to slam into a wall. I can't slip in there.
Right.
So absolute values are walls. Nothing can go in. You can only bring things out. So this is the negative gets carried down. And then I take the absolute value of negative 12. Well, the absolute value of negative 12 is positive 12. So this is actually going to stay negative because you bring it down. Negatives that can't go into anything, like this absolute value or whatever, I call these guys like stalkers or lurkers or creepers. They just hang out, right? So we just keep them there. Okay. And same thing with this. The absolute value of 7 is 7. But that negative could not go inside because it hit a wall, so we bring it down. So this is negative 7. So you can bring negatives into parentheses because you have that nice curve you can slide into, but with absolute value it's a wall, so you can't go in. Does that help? Okay, finding the opposite of an integer? Yeah, so that's going to be negative 4, and that's going to be positive 99. Okay, so adding integers is adding positive and negative numbers. Okay. There are multiple ways to visualize adding positives and negatives or integers. So if we use a number line, positive numbers move to the right towards the positive side. Negative numbers move to the left. So if you're going to use a number line to add, what you do is you have to create a number line. And you don't have to label everything, but you start with your first number. So 1, 2, 3, 4, 5. We're going to start with 5. And we're adding 3 to that. So from where we start, I'm going to go 1, 2, 3. So that's adding 3. And that took me to 6, 7, 8. So 5 plus 3 equals 8. Now I know I did not have to show you this on a number line. You guys know how to add positive numbers, but it's a good example for showing you how to use the number line. Okay. For B, again, we create our number line. Does not have to be perfect or pretty. We always start at the first number, so I'm going to start at negative 5. So 1, 2, 3, 4, 5. And again, I'm adding 3. So I go 1, 2, 3. And that lands me at negative 2. So negative 5 plus 3 is equal to negative 2. But then I'll show you what to do in place of a number line. So if we're going to start with a positive 5, so I'm going to start at 0 and I'm going to go 1, 2, 3, 4, 5. This time I'm going to add a negative 3, so I'm going back 3. So that's plus negative 3. So negative goes in the opposite direction, and that lands me at 2. So 5 plus negative 3 is equal to 2. And if I start at negative 5, then I add -3, so I have 1, 2, 3 again. That lands me on -8. So -5 plus -3 is equal to -8. You guys have been doing adding thing for a while. Positives anyway. Okay. Any questions on adding numbers with the same sign? Okay. If we have different signs, what you're going to do is you're going to subtract the numbers. Okay, and I'm going to put bigger in quotes here because a positive number is technically always bigger or greater than a negative number. So +2 is bigger than -10. But I'm putting bigger in quotes because in that example I would say 10 was bigger than 2. So what I do is I subtract the numbers. So 2 plus -7, I'm going to do 7 minus 2 is 5, right? So 2 plus -7 is going to equal -5. And the reason it's -5 is because the 7 was bigger and the 7 is negative. So it wins. So the answer stays negative. -6 plus 24, well, 24 minus 6 is 18. -6 plus 24, well, the 24 was positive, so my answer is positive. And anytime you add opposites, they cancel each other out. In this example, I have $2 and I owe you 7, well then I'd still owe you 5, right? If I have $24 and I owe you 6, that means I get to keep 18. And then if I have $8 and I owe you $8, we're even, right? So if you think of it with money, that sometimes helps because you guys are... There are 2 ways to approach this problem. Method 1 and method 2. Okay. Method 1 involves leaving everything in the exact same order it's in. And adding it in parts. Okay. So I usually just do 2 numbers at a time down the row. So -30 plus -12, they're both negative. So I'm going to add those together and I'm going to give -42. And so far nothing else has changed. -42 plus 4. Different signs, so I'm going to subtract. 42 minus 4 is 38, and it's going to be -38. And then I have -38 plus -10, they're both negative. So -48. And then -48 plus 6, they're opposite signs again. So I subtract, 48 minus 6 is 42, so it's going to be -42. Okay, that's one way to do it, just in parts. The other way to do it is to take that problem and rearrange it. And what I'm going to do is I'm going to put all of the negatives together. Right? So I have the -30, -12, -10. All the negatives are together. And then I put the positives together. And I usually cross them out as I go just to make sure I don't miss anything. And then what I'm going to do is I'm going to add up all of the negatives and all of the positives separately. And the reason I do that, if I rearrange them, is because all the negatives, I know I can just add the numbers together and my answer is going to be negative because I'm adding up a bunch of negatives. And then the positives, I can add those together and it's going to be positive. So I say 30 plus 12 is 42 plus 10, so that's negative 52. And then 4 and 6 is plus 10. And then I go, okay, these are opposite signs, so I'm going to subtract, and I have negative 42. We're going to turn this sentence into math. Now, added to is plus, and sum is plus. Those both mean plus. So if I take negative 6 and I add it to, this is being added. That's what this is saying. This is 2 plus negative 11. So I'm going to add that to 2 plus negative 11. And again, you can either do this in parts or you can rearrange it. So I'm going to write it down twice. And we'll do method 1 and method 2. Okay, so method 1 is to add these two together first. And I have a negative 6 and a positive 2, so I'm subtracting them, and that gives me negative 4 plus negative 11. And then I'll add those two together. They're both negative, so they combine, negative 15. And for method 2, I'm going to rearrange it. Whoa, I forgot the plus. Totally different sentence that I just wrote there. Plus negative 11. Okay. So for this method, I'm going to rearrange the problem. So I'm going to put the negative 6 and the negative 11 together, and then the positive 2 by itself. I'm going to take that negative 6 and that negative 11, and I'm going to combine them to get negative 17. And I'll add 2 to that. And then I'll add those two together, and I get negative 15. For this problem. So, late spring and summer rainfall in the Lake Okeechobee region in Florida. It is important to replenish the water supply for large areas of South Florida, otherwise known as the Everglades. The graph indicates the number of inches of rainfall above or below average for the given months. There's our graph. And we want to find the total departure from average. So average ends up being 0 on this problem. Our average isn't 0, but average on the line would be equivalent to 0 because we're talking about departure from average. Okay, for those months. So do the results show that we received above average rainfall or below average? So we're going to come back to our graph. So here's our average as at 0, and departure from average are the positives and negatives. So here we have a plus 2, and here we have a minus 6. Here we have a minus 4. August we were exactly on average. And then September we have a plus 4. So far so good? And then we want to see, do we average out? So I'm going to put my 2 positives together and my 2 negatives together. And my 2 positives are going to give me a 6. And my 2 negatives are going to give me a negative 10. And when I add those together, I'm going to be negative 4, which means I'm 4 inches below average rainfall for that summer. Okay.